guys. Guys. Good. So, I think we're gonna start. Let's see. First, a couple of comments on the homework because I've already been grading a couple of them. So, yeah, I noticed that a bunch of you just use the solutions from last year, which is fine by me. Like, it makes it easier for myself. But you know, you're just losing on yourself because you probably should have guessed by now that you were gonna pass anyway the homework assignment. Just the fact that you get more exercise. But again, for me, it makes things easier because I just check, and move next. But a couple of comments. I'm just gonna give them right here. First of all, the intermediate value theorem seems to be a mystery for most of us. I'll write it. I'll just write it here because it's one of the two theorems that when you're stuck, if you have in the back of your head and you use it, you might just save yourself a lot of headache. Like it was the case in problem number B. There is literally no way to solve it outside of using this intermediate value theorem. If you didn't think of it, then you would have reached the problem on the exam where you're stuck on part B, which never feels good. So I'll just write the intermediate value theorem once, but I don't, you know, I think you've studied it a couple of times by now. So, or at least I've been told that you've had it in several classes in Math 1 and Math 2, I think. That's what I've been told, but I'll just write it out. So, because it seems to be a mystery to literally everyone. Okay, intermediate value theorem. I'll give you two definitions. I'll give you formal definition and I'll give intuitive how to use definition. So let's start with the formal one. Formal sounds something like this. If f continuous if f is continuous and if f of a smaller than some c and f of b, okay, let's use c, that's fine. Okay, if you have this, sorry, like this, then you get that there is x, or in your case a big T, such that, let's use big T, f of t is equal to c and t is in a, b. Okay, that even equal doesn't matter, to be honest. Well, formal definition of the intermediate value theorem. If a continuous and you have f of a smaller than c, f of b greater than c, then there is a t such that in this interval a, b such that it's equal to that c. Now, formal definition. Nobody uses the formal definition. Simple, intuitive. Intuitive. If you are looking for some f of t is equal to 1, find me two values, f of a greater than 1, f of b smaller than 1. And you are done. Okay? So basically, if you're looking for a solution to an equation or something like that looks like this, just find me two values of the function, one bigger, one smaller. Okay? That is the whole idea of the intermediate value theorem. The drawing is even more intuitive. The drawing looks like this. What number do you guys want me to look for? Let's look for 47. Okay? I'm looking for some f of x equals 47. I'm just looking for it. I need to show this on the exam. At this point, if I can just find, and I'm gonna give examples, f of 1 is equal to 20, and then f of 3 is equal to 100. So let's put 1 is here. I'm gonna reach 20 here. And then f of 3 here, which is 100 here. The whole idea of the intermediate value theorem is that for me, in order to go from here to here, I will cross this line at some point, which is going to give me a solution. That is the whole idea of the intermediate value theorem. Okay. I just wanted to specifically write it out because I've seen it applied in so many different ways. You guys have no idea. Now, another thing that's been destroying us, if there are no questions on this, area under the graph. Under the graph. I use this definition for the integral, which is perfectly correct. The problem is in establishing what area under the graph is. If your graph looks like this, everyone did it correctly. This is your area under the graph. If the graph looks like this, then here comes the problem. The area under the graph here is this thing. Okay, I thought it's pretty clear. And the idea in integrals is that this is positive, this is negative. So I thought this is pretty clear as well. Okay, now outside of this, I think outside of points B, C, D, and E, everyone did well on the others. Maybe some problems on G, but everything was fine otherwise. Yeah, implicit differentiation, I don't need to tell you that you might need some help on that, but you know, I don't have like all lectures to start doing all the material that is a problem, but I just wanted to give attention on these two because extreme value theorem, people seem confident on it. Intermediate value theorem, everyone is just applying it, some sort of, oh, I'm stuck, I have no idea what to do, I'll just apply intermediate value theorem, and the applications have been wild. I've seen it applied on problem number D, if I can tell that, on the partial derivatives. So yeah, it's been quite impressive. Anyway, coming back to what I'm actually supposed to do. We're gonna do differential equations today. We're gonna just introduce that concept, and we're actually gonna solve some stuff today. Okay. Just to keep in your head, how these different what they are, how do we use them, etc., etc. This x squared plus bx plus c, this is your quadratic. Okay, everyone's worked with it, everyone is hopefully comfortable with it. The quadratic equation, right? Over the quadratic whatever, or ABC rule, I don't know what names you have for it, I call it quadratic. Now, the difference in differential equations is the fact that instead of this x squared, you just have an x dot here. Bx plus c is equal to 0. This is a differential equation. Okay, this x dot is just derivative of x with respect to usually time. Okay, let's give the formal definition of what a differential equation is. And for this, I actually need to look it up because I've never memorized it. So never had to use the definition. But here it is. It's an equation for an unknown function. That involves some derivative of that function. Hopefully now you see why I have never used it. It doesn't really say that much. Okay, it doesn't really help you. So the idea is that your x depends on t. Usually time. Usually t is time. But it can be multiple things, okay? So your standard, or the one that we are going to do in this class, the first one at least, is going to be x derivative of t plus bxt, no derivative, plus constant is equal to 0. Wait, this is the one we're gonna try to do. If by the end of this class, hopefully, once you get something like this, you would be able to compute x of t is equal to what, how does it look in order for it to satisfy this equation? And it's not that hard, okay? But first, let's look at the terminology. So we're gonna study, let's flip the page. We are gonna study first order. I think we ordinary differential equation. Okay. What is let's look at differential equation. I think at this point we know it means it's an equation that has some derivatives in. First order means that the order of, highest order of the derivative. Okay, highest order of the derivative. Since it's first order, it means you're only gonna work. You are only going to work with first derivative. Okay. And then ordinary means only one variable. Okay. Your functions will only depend on one variable, and I'll say it again. Usually t time. Okay. And I'll even write x of t. Well, so this is, now that we all kind of have it set up, let's look at the terminology again. X of t, this is what you need to find out. You need to, by the end of your work, if you've solved it, quote unquote marks, you need to give me a formula for this. So this is what you need to find out. Now, this t is your variable. Again, time, usually. And this is your unknown function. What is it? What does it show you? It shows you how x depends on time. Okay. This now they're different. Now, okay. And there are different examples for this. Different. I just know a bunch from physics, but in economics, I don't know. You could have maybe x being the liquidity, the money that the bank has right now in its reserves. It's a function that depends on time, and it's obviously has a differential equation that it's top secret, of course. And bankers need to know this, for example, or stuff like that. You can have from smart examples just as the bank reserve to like I don't know, if you just leave your bath running, your tub running, when it's got to fill with water, kind of thing. So it varies. All examples vary. Differential equations are used in everything that is called continuous time. Okay, time is continuous. We can't slice it up, so that's why they're like essential for anything that is real world for them. Now, different notations for it. X dot is what is standard to be used in the class for the derivative. This is the same as writing derivative of x with respect to time, which is the same as writing x prime of t. Now, why do we use x dot? I have absolutely no idea, but everyone is using x dot. So we should be using x dot. It sounds sad, but that's the way the word works. Just remember, and I'll write it out just so we're clear on it. X dot is just the derivative of the function x with respect to t. Okay? Everyone uses a x dot. I have no idea why. Again. Somebody talking in the room next or something? It's like a microphone or whatever. Okay, now let's rephrase what you're supposed to do. You will be given a function that usually is going to look like x prime of t, again, or x dot, if you want to be smart on the first hour, xt plus c is equal to 0. Okay? And then you solve it, you do your work, and you're supposed to give me x of t is equal to the formula. This is the standard way to solve it. Now, there are things called particular solutions. General versus general solutions. And we're going to see more of how it looks. But particular solution versus general solution, as you probably can tell by the name, particular solution only works in some cases. General solution works every time. Okay? Pretty standard. I don't think I need to explain everything like this, but I'll give an example. For example, if my general solution is a constant times e to the power of t, then a particular solution might just be 24 times e to the power of t. Okay? So the difference basically from the general solution to the particular solution is that you can give values to your constants. Now we're going to see exactly how to solve and where do you get those constants and whatever. Let's actually try to solve it, and then then I'll show you more about particular solutions. Okay. Now, the way I learned it many years ago is using this bxt plus c notation because it was introduced really early. Now, the way it's introduced in your book, I have to look for a second, is like this. Let's look at how to solve an ordinary differential equation. It's called ODE, makes sense. So the way to solve it is, the answer to this is, it depends what case we are in. We have two cases. So the first case is the linear case. In which you have x dot plus x at is equal to bt. This is how it's introduced in your books or whatever. Okay? Which, just a small parenthesis, you can tell that it's just the one I wrote before, just with different constants, right? It's just the same as this, but with different constants. So this is the linear case. And then it's the separable case. In which you have x dot is equal to f of t g of x. These are the only two cases you are going to learn in this class. And I am going to assume that they look very, very different. Like you can't really mess them up. Okay? Hopefully not. Now, let's start with the first case. They were only going to do the linear case, and we're going to work on basically cementing everything that's particular, general solution, the notations and everything because it's new. And tomorrow we're gonna move to the separable cases. So yeah, I think none of them are harder than the other. Both of them are basically just completely standard. Like you even have the formula for it. Basically, when you see a linear case, a linear differential equation, let's actually, let me write it and then I'll explain exactly. Linear differential equation. Again, we'll use the notation that you guys use. X dot plus AT X is equal to B of T. Okay, let's have a reminder. This derivative with respect to T, and these are just functions of T that you know. Like for example, you might have, I don't know, like you might have, I'll write here examples. You might have to solve X dot plus 2x is equal to T squared, or X dot is just equal to T, or X dot plus something very ugly, I don't know, 2T ln of T, X T to the fourth. Okay, I think everyone kind of understood what it is. It's basically just to be exactly clear how this function looks like. Now, the steps are really telegraphed. Like whenever you see this, there's no intuition to it. There's nothing to it. It's just a standard method of calculus that you need to memorize. Okay, so first of all, you need to compute big A of T. Okay, using our notations. What is big A of T? Well, you guessed it. Antiderivative of AT. So yeah, that's why I said that they're just like all differential equations are just undercover integrals. Literally, when you see a differential equation, you just got to compute an integral. The formula is standard. Okay, antiderivative of A of T. Pretty important, no constant to it. Okay, no constant to it. And then basically you just plug in the formula and you are kind of done. Let's see if should I give you, so I'll give you the idea of how to compute it since that's how I know to do it. But on the exam, feel free to use only the formula. I think it's given in your cheat sheet at the end, actually, the formula. Like you can just take it and plug it in. Nobody's going to say anything about that. That's how everyone would solve it. This is just the first lecture, so I'll show you how to solve it, kind of. But again, on the exam, feel free to just use the formula. The way the way you solve this, everyone solves it this way, is to just have this equation, and which is X dot plus AT X plus B of is equal to B of T. And you multiply this by EA of T. Okay? And you get the following. You get EAT X dot plus AT X is equal to EAT B of T. Okay. Now, I'll actually split this for a second. Test your intuition. See if you see exactly why we did this whole trick. Which again, you don't need to memorize. You can just keep in mind the final formula. Nobody's going to say anything. Okay. So I said EA of T. Sorry, big A of T. The antiderivative. Sorry about that. Big A of T again. A of T X times A of T is equal to E A of T B T. Okay. Can anyone just by looking at the left side have an idea of why we have chosen to do it this way? Does anyone have any idea why I've chosen to multiply with EAT? Just looking at the left side. Okay. My claim is that this left-hand side is just EAT times X derivative with respect to T. Can you guys see it? Like, just attempt to take a derivative of this thing. Okay, and you're gonna get exactly the thing up top. Let's actually do that together. So that you're convinced, I guess. So again, if we take derivative of this, we just have a product rule. So I have EAT times AT derivative times X plus EAT times X derivative. Okay, this is just equal to EAT. If AT is the antiderivative of small a, then if I take a derivative, integration, derivation, opposite, this is just AT times X plus EAT X dot, I think we used. Yeah, X dot. Okay, see what I mean? It's the exact same thing. And somebody brilliant came up with this idea. I don't know who it was, but it was definitely not me. So they just noticed that if I multiply by this big EAT, everything will look nice. Why? Because I can integrate this thing. So I will integrate both on both sides. dt. Again, think about it logically. Why would I want to integrate? Because integration, opposite of derivation. So from this, I will just get EAT times X. And here's something that some people might forget. What else we have here? A constant. This is where the constants actually come into play and they partially matter. Okay? Plus constant is equal to integral EAT BT dt. Does everyone understand why I got from here to here? Integration, opposite of derivation. I have integral of a derivative, I just get the thing before. Okay? Think of it as I'm adding one and then I'm subtracting one. They just cancel out. So I get this, and now the problem is done. Why? Because X of T, my final answer, is just equal to this C. I move on the other side. It's a constant, so it doesn't matter if it's plus or minus. E to the minus AT plus E to the minus AT integral EAT BT dt. Okay, and this is the final formula, which again, feel free to use. I'm pretty sure it's at the end in your cheat sheet thing, so you don't need to stress about it. Okay. Now, literally, this is everything you need to know about linear differential equations. You need to know how to identify it. You need to know when you look at it, what is my AFT, what is my BFT, and then you just need to plug it in and get your result. That is literally all. I'll show you. Let's take the simplest example. I don't know. Let's just take A of T. Oh, sorry. Let's take simplest one. Let's take X dot. Okay, let's take X dot plus X is equal to 1. Okay, I'll push the papers back. Let's compute the answer to this. How do we start? As I said, you first need to identify it. I notice it's a linear. Okay. I'm in my first time solving this. So I just write x dot plus ax x equals bx. Okay. Cool. Now I just write it. Ax is equal to 1. Bx is equal to 1. Now, I look at my steps. What was my step? My step was compute antiderivative of at. Cool. I do that. If a of x is equal to 1, a of t. Apologies, a of t. A of t, of course. Okay. If my a of t is equal to 1, then my big A of t is equal to integral of small a of t dt, which is just integral of 1 dt, which is just t. Okay. That is my integral. That is my a of t. And now I am done because I basically just say, okay, xt is equal to constant times e to the minus t plus e to the minus t. Again, I'm just using the formula above and I'm replacing my a of t. That's literally all I'm doing. Integral e t times bt is equal to 1 times 1 d of t. Does everyone understood exactly what I did here? Because everything is repetitive. So again, I look at my equation. I notice it's a linear one. I just identify my a of t and b of t. Look at it, a of t, b of t. Okay. Hopefully you didn't write a of x and you actually wrote a of t, unlike myself. So you notice this is 1. You do the first step, compute the antiderivative of small a, big A. Compute it. It's equal to t. And then I just plug in my formula. X of t is equal to c times e to minus t, because I had minus at up top. Maybe I had it. Okay, let's say green. So again, I have gotten that a of t is equal to t here. It's kind of the same, to be honest. Okay, and now I'm just replacing it in my function here. This a of t over here, t here. A of t over here, t here. A of t, and then I just got to replace my b of t at the end, which is 1. So hence the 1. Good. You have successfully solved this differential equation. Now, I lied a little bit. You have partially solved it. You need to solve this integral. That's why I said the linear differential equations are just, or differential equations in general, are just integrals hidden as that thing. Because right now I need to solve this integral. So luckily I gave it as an easy example because that's just e of t. C times e minus t plus e minus t times this integral is just e of t. Notice I am not going to put another constant here. Why? Why would I not write something like this? Plus, write it with green. Why am I not writing it like this? Why am I not putting a constant there? Because, integral of that should give me e of t plus a constant, right? Why am I not doing it? And the answer is because it doesn't make sense, because I would get constant times e to the minus t. I already have that element here. And being that the constant can be whatever, I don't need another one. So don't fall into this trap, okay? I don't need to write it. because I would just get another constant times e minus t, which I don't need. So in this case, careful. I don't need this. This is enough. Okay. So my final answer is just x of t is equal to c e minus t plus e to the 2 plus 1. Okay. This general solution. Okay. Sounds like a cartoon thing. This general solution kind of thing. Okay. So this is it. This is all that you need to know in order to solve differential equations. Obviously, at this point, if you're happy with integrals, then this is just gonna look like a formula that you're gonna use and then compute the integral. If you're not good with integrals, obviously this is not gonna make it better because you need to compute more integrals here. Another type of thing that you might be asked is, let me see if I have an example for that. I don't actually. Okay, so before we go to my example, how do you check if your general solution is working? Let's see if I did it correct. How do you check if it's working? I just take it and I plug it in my formula. Again, my formula was x dot plus x is equal to 1. Okay, this is the derivative. So what is x dot, which again is equal to dx dt dt is equal to x prime. I just take a derivative of this thing. Okay, so that's just equal to c times minus t derivative minus 1 e to the minus t plus 0. That is the derivative. So now what I do, did everyone follow me on the derivative? Was it too fast? Okay. So now what happens is I just take this and I plug it in. So I take this, plug it in here. So I get c times minus e to the minus t plus x, which is that thing, c e minus t plus 1 is equal to 1. And then you see that things cancel out. This cancels out with this because 1 is a minus, 1 is a plus, and this is 1 equals to 1. So it just magically worked out. Right, this is how you check if you're unsure of your result. Now, some problems. So this is general solution. I hope we all agree that's the general solution. Some problems might ask you for solve the linear differential equation and then find the solution such that and then they give you some formula like x of 1 is equal to 5. Okay, this is a phrasing that you are definitely going to find. Find the solution such that, and they give you some random stuff here. How do you do it? It's actually simpler than you think. Once you have the general solution, we have the general solution here. What do? I'll write it here just so you can see it. X of t is equal to c e minus t plus 1. I just plug in 1 inside and I get c times e to the minus 1 plus 1. And I put the condition this to be 5. Okay. So what they're basically asking in this thing is for you to find the corresponding constant, that's c, such that you get this thing. Now I just solve this for c, and I get c times 1 over e is equal to 4. So c is equal to 4 over e, and I am done. That is all. If you want, you can write it specifically like x of t, and you just replace your constant. 4 times e minus t plus 1. This is constant. I just plugged in here. Okay, it's not. These are all the questions you can get on linear differential equations. There's nothing strange or interesting that can happen here. It's just a test of, when you see a differential equation, it's a test of, can you identify it if it's linear or separable? Can you use the formula for linear? And then can you compute the remaining integral? Those are the three questions. If you've answered those, then you can solve any differential equation that you can find. Now, we're just going to take some examples just to more or less stabilize the notions, but let's take a break right now. I think it's a great time. And then we're going to take a bunch of examples, hopefully answer all your questions that you might have. Okay, guys. So let's get back into it. Again, we're just going to take examples from now on. That is literally all the theory I can give you. Now, again, it all comes down to solving integrals. Sometimes the integral might be hard, but if you are not writing it in like the final form, which is the general solution form, which doesn't mean solving any integrals outside of like the A case, which is going to be simple all the time. If you're not writing it, somebody take my paper with the solution. Yeah, we're gonna solve it again. I mean, I'm gonna solve it again, and we're gonna, yeah, because I can't find it anymore. Okay, cool. So let's take an example. I don't want the emphasis to come on the integral, so that's why I'm gonna take some simple relativity examples. So let's take x dot. So let's actually formulate it as an exam question. Consider the equation x dot plus 2x 2tx, let's put a t here, is equal to 27t. Okay, consider the equation. Find the solution such that x of 1 is equal to 2022. Okay. How would we attack such a problem? The first thing that we need to do is identify our AT B of t. So x dot is equal to 2t plus 2tx is equal to 27t. And your general equation looks like this: x dot plus ATX is equal to B of t. So first thing, identify A of t and B of t. So this is the first step you do in such an equation. We identify it, right? A of t equals 2t, 27t equals B of t. I write it out. A of t is equal to 2t, 27t is equal to B of t. I don't know why I put a t here. I'm just tired of this. Okay. So I identified the two. Good. What's next? Compute A of t, which is again integral small a of t dt. A of t is going to be integral 2t dt, t squared. No constant. We specifically said no constant because there's no point in putting another constant. Cool. Once you've done this, plug in the formula. Plug in the formula. What was the formula? I think it was x of t is equal to the constant times e to the minus at, so that is minus, okay, let's write the formula again since we are missing it. I don't know who took it. Okay. Integral of EAT BT dt. Okay, this is the formula. I'm just gonna plug my A of t and my B of t inside. So I get x of t is equal to c times e minus t squared plus e minus t squared integral e minus t squared. What is this? 27t dt. Okay, so on the exam, what I'm saying is that you're losing mostly probably at least half of the total score if you don't write what I just wrote. Now, solving this integral might be hard at some points. I understand that. But there's no excuse for not writing this thing. Though I didn't compute anything. I just knew the method and I used the formula, which if you can't memorize it, I'm pretty sure it's going to be given in the cheat sheet. So there's no excuse for really not doing all that I've done. Okay? Because you're losing half the points for nothing, basically. Now, the next step is actually solving this thing. Okay? Let's put it as number 4. So any questions on what I did? So again, I considered this is an exam type question. I don't know what values they're gonna choose there, but the exam question is 100%, if it's linear, gonna look something like this. Consider the equation and find a solution such that whatever is equal to whatever. I gave 2022 because it seems to be like the thematic. So first of all, you identify your A, T, and B of T. How do you identify them? You just do it like the simplest, obvious way. You just write them like this and you make them equal. Okay? I identified it. Then I computed A of T, which is just integral of 2t. And I'm expecting this integral that you're computing here to be very, very simple. Okay? The reason being is if this is not simple, then the final integral is going to be unsolvable for you guys. So I'm expecting this to be very, very simple for you guys. And I hope everyone can just compute integral of 2t and know that it's t squared. Okay? And at this point, you just have that t squared and you just literally plug it in. At this point, if you stop and write, I have no idea what's next, you get half the score. Not because the grader is nice, but because the grader has to give you these. Okay? Now, solving them is a whole different thing. Let's see how we solve it. Okay, so point 4, if you want to have it, if you want to stick to the 5-step plan or whatever. Problem 4, solve the general equation. Okay. When they say solve the general equation, they're basically just asking me to solve this integral over here. Obviously, there's nothing else to solve. T squared, and we just try to address it as any normal human being, I guess, trying to solve it somehow. E minus t squared t dt. Now, for this, there are like multiple ways in which you can solve it. You can even, like, by now notice that this thing is just this whole thing is just derivative of this. There are multiple ways for you to notice or solve it. The emphasis that I want to put right now is not on how to solve the integral. The emphasis I want to put is on how to solve the differential equation, basically the roadmap you need to follow. So I think, or some of you might notice, that this is just e minus t squared minus over 2. Okay, it's just that derivative. If you don't know, you can solve it by parts, substitution. Literally use anything you want, everything works. But again, I don't want to put emphasis on this. Just checking that my math is right for a second. It's correct. So my x of t is equal to the c e minus t squared plus e minus t squared times 27 times minus e minus t squared over 2. And at this point, I am done. I have solved the general equation. There's nothing else for me to solve. Can I make it look a little bit nicer? Sure. Does it matter? Absolutely not. Okay. Now, last step is x. So this is the general solution. Again, general. When they're asking for x of 1 is equal to 2022, they're asking for a particular solution. How do you do that? You just plug in t equals 1. Plug in t equals 1. So I just get x of 1 is equal to, and I'm using my formula, c times e minus 1 squared plus e minus 1 squared times 27 times minus e minus 1 squared over 2. Okay? And I need this to be 2022. So they're basically just asking me to compute the c such that this works out. So I have c times 1 over e plus 1 over e times 27 times 1 over 2e equals 2022. And I care so little that I'm actually just gonna write it like this. This is just equal to e times 2022 minus this whole thing. I'm literally not gonna touch it because I don't really care about it. Okay, I just got c out of here. This is my constant. That makes it all possible. And at this point, you get like all the points because this is literally what you have to do. If you want to be extremely formal, you could just do something like the solution is, and then you write your general form, this one, and plug in c inside. So I'm not going to do this, but I'll just write the general form. The solution is xt c e minus t squared plus e minus t squared 27 e minus t squared over 2. And you plug this c in here. Okay? If you want to be formal. So this is how you solve literally any linear differential equation. I don't know what else to show you. I can just give you examples. It's just a matter of if you have questions or you don't understand something that I did in my process, because now I'm just gonna give you like some other examples, and that's kind of it. This is all that you need to know about differential equations. Again, when we're given an equation, you just first identify your AT and BT, because okay, if it's linear, if it's separable, we have some other methods which we're gonna do tomorrow. But if it's linear, you just identify your parts, you compute the integral of the small a, which again I think should be very easy all the time, and then you plug in the formula, your AT, and then you solve the remaining integral. Once you solve the remaining integral, you get a general solution. And then if they're asking you for the particular solution, you just plug it in and see what your constant is. Those are literally 99.9% of the problems you're gonna have. Now, I guess I can just do one trick question. One fast trick question is, consider all that blah blah, consider x dot being equal to 1. Find me the solution x of 1 is equal to x of 20 is equal to 22. Okay, now something like this. Okay. How would we solve this? Well, any ideas right off the bat? Well, the first idea that I'm going to give you is to never ever keep track of what that x dot is. That x dot is just the derivative of x with respect to t. If I tell you that the derivative of x with respect to t is 1, then it means that x is just t plus a constant. Right. This is the completely informal way, and I just wanted to remind you that to always keep in mind that x dot is just the derivative of t, nothing more, nothing less. So in this case, the way I would solve it, I would just do this, and x20 would just be 20 plus constant. I need this to be 22, so the constant is 2. So my x of t solution for this would be t plus 2. Okay, this would be like my observational thing. Again, if it's something really obvious, just use it to your advantage. Nobody's going to give you a prize for overcomplicating it yourself. Now, if you didn't notice this, or you just wanted to use the formula, this is just equal to x dot plus 0 is equal to 1. This is equal to x dot plus 0 times x is equal to 1. And now we do all the things that we did previously. What's our first step? Identify. X dot plus at times x is equal to b of t. Identify. A of t is equal to, what is it, 0? A of t is equal to 0. B of t is equal to 1. Great. Next step. A of t is integral of 0 d of t, which is just, I mean, this exercise doesn't really make sense, but it's just the constant, okay? It's just the constant. Now, you don't need to put the constant, so we can just leave it as 0. I'll just leave it as 0. Now, apply the formula. What's our formula? I'll write it myself since it's easier for me to remember. EAT times a constant plus E minus AT integral EAT times B of t dt. X of t is equal to e to the 0 times a constant plus E0 integral E0 times 1 dt. So x of t is just equal to a constant plus what is this integral plus t. So we got to the exact solution that we got up top. Okay? Okay. Any questions on this simple example, on the procedures that I did here? I think realistically it should be pretty standard. Now, the only thing that's going to get trickier is this last integral that you need to compute. That is the only thing that's going to get trickier. Usually, what I've seen that people have done in the exams is they first ask on point B to solve the integral, and then on point A they ask you to solve the integral, and on point B they give you the differential equation such that this thing is that exact integral you solved in part A, so you can just replace it. Disclaimer: even if you didn't solve part A, you can use it in part B. But we'll go for that in exam prep if we still hold those out. I don't know if we do. Okay. I don't know. I can just look for an example. I'm trying to find something not too complicated, not too easy either. Let's think of it this way. Let's have an x dot. Oh, let's actually complicate it a little bit. Let's do a 3tx dot plus t to the third x is equal to t e to the something. I don't know. Let me give you a second. To t to the third. Sure, let's do that. Okay. This looks like a step up, right? Like it looks a little bit harder. A little bit at least. Oh, thanks. Let's put over 3 here because I want to, because I feel merciful today. Okay. How do we do this now? This doesn't really look like our equation, right? What we're used to is x dot plus a t x b of t. It doesn't really look like what we know, right? Because we have this free t here over here, which is kind of bothering us. So what can we do with it? We can just divide it. We just divide the equation by t, by free t. I divide by free t. Why? So I get to something that looks like this. So if I divide by free t, I get x dot plus t to the third free t x is equal to t e minus t third over 3 over 3 of 3t. Everyone on board with this? Again, I divided by 3t because I wanted to get to the equation that looks like this. I only know this equation. That is what I need to bring it to. Again, I come back to the same saying. What is it? Necessity shows the way or something like that. I'm liking the expression right now, but necessity always brings the way. Okay, scratch that. Well, I'm going to remember it by the end of the lecture. Okay, cool. So now what can we do now? We can just identify the stuff. Plus at x is equal to b of t. Identify the stuff. A of t is equal to this t third free t. Okay. Okay, that's fine. B of t is equal to e minus t third over 3 over 3t. Okay, 1 second problem. Okay, let's put 9 here because I'm still nice. Well, let's leave it as 3 for now and see what we get. Okay, cool. What's the next step? We get a of t is equal to this thing. A of t is equal to integral t third 3t dt. That's equal to integral t third t second over 3 dt, which is just equal to integral 1/3 in front t squared dt. This is just 1/3 times t to the 3 over 3. Okay, and yeah. Okay, fine. All right, let's make it. Let's put 9 here. I like 9. Let's put 9. Makes simple. Okay, I'm doing this for you, by the way. Okay, so I computed my A of t. What do I do next? I plug in the formula. I'll write it again. Constant times e minus at plus e minus at. I keep on writing it because although you will have it on the cheat sheet, or it was on the previous years, It's so much faster if you have it in your mind and you replace than wasting time finding it in the formula sheet until you find it, until you remember it, until you whatever. It's just easier if you can keep it in the back of your head. So we have x of t is equal to c times e to what is a of t? A of t is t to the third to the 9. So minus t to the third 9 plus e minus t to the third 9 integral e minus t to the third 9. And what is my b of t? My b of t is just t e to minus t to the third 9 over 3t. Sorry, there's a plus here. There's no minus here. Apologies for that. It's a of t here. It's plus here. I don't know where I created the minus from. Okay, dt. So this is the thing you got to compute. And it might look menacing, but the whole idea why I struggle with the 9 and the 3's there is I didn't want you to waste time, or I didn't want us to waste time in computing this integral, because this thing just simplifies away. Okay, it's the same thing. So what I have left to compute, and this t goes away, so I have left to compute is c times e t to the third over 9 plus e minus t to the third over 9 times integral 1 over 3 dt. And this is clearly just x of t is equal to constant e minus t third over 9 plus e minus t third over 9 times t of t over 3. And this is it. This is my general solution. They didn't ask me to compute a particular solution, so I'm just gonna leave it at this. This is me solving it. Now, I'm not gonna lie, initially I wanted to give the integral here. I don't want to simplify. I wanted to give like a substitution thing, but then I thought it might be too much, I guess. So this might be part A, compute the general solution of the solve the differential equation. You solved it. Part B might be find particular solution such that x of 3 is equal to 147. Okay, what do we do now? We take our general solution from above, plug in 3, plug in e equals 3, and you get x of 3 is equal to a constant e minus 27 over 9 plus e minus 27 over 9 times 1 has to be equal to 147. Remember, the constant is what they're asking me to compute. So the constant is just from here, 147 minus e to the minus 27 over 9 times e 27 over 9. I think I could have simplified this by ages, like long ago. This is just 147 minus e to the minus 3 times e to the 3, and I'll just leave it like this. I don't really care. And again, since you don't have a calculator on the exam, you're not allowed to have a calculator. I would suggest, if you get something like this, I would suggest not losing time to give me an approximate value for this. It's not going to help me if you tell me this is approximately 514 or something. I really don't care. Yeah, I've seen people on the exam trying to do this, and they literally spend like half a page trying to compute this and give me an approximate answer. I actually don't care. Nobody cares. Okay, so now my xt particular solution is plug in this constant in the general. 147 e minus e3 e to the third e, and you just copy the rest because it's literally what you have to do. This would be like if you want to write the formal answer, like you just write like this. Okay. where again, this is just the constant. Okay. Now, let's see how much time we have. Let's see what we can do. We have 20 minutes left. Let's actually, like again, let's actually look at an exam, because I'm pretty sure this is literally the standard which we can do. See this one. That is not. So this is a separable one. We're not interested in a separable one. That is not what we're looking for. Okay. Okay. I only see separable. Okay, I'm kind of getting bored. Let me just invent one. So we're gonna have e to the t 2e to the t x dot plus, no, let's put minus actually, minus e to the t to the second times 1/4 x. This is equal to e over, this is getting ugly. Okay, et times e, everything like this. Okay. Okay, I'm happy. This looks about right. Okay, take this equation, find solution x of, what are we today? 7. X of 17 is equal to 10. Great. Sure. Now let's try to solve it. Okay, scratch that one for me. Again, I'm feeling nice today. Okay. Great, just take 5 minutes to solve it, and then we're going to solve it by ourselves. Just take it slowly, step by step, exactly how we've done it up to this point. I hope everyone copied that. I'll just give you like the step page if I can find it. Yeah. Here's my step page. Just, yeah. This should serve as general guidance on how to do it. Okay, I see a lot of raised heads. I assume everyone is done with it. So let's solve it. What's the first step that we do? Always, we identify our AFT and BFT. What's the problem in this case? What's my formula? My formula is x dot plus ATX is equal to B of T. Correct? This is fine. Like the right-hand side is fine. The problem is here. Okay, that is a problem. So what do we do now? We just divide by ET. Divide by ET. And we get. So wasn't this supposed to be a point here? I think I was supposed to be a point here. Like problem number 2. That's what I meant. Anyway, good practice, guys. Good practice. Good. So I hope you all divided by that thing. Otherwise, you would never solve it. So you divide by it and you get problem number 2 again was supposed to be there. So you get x dot is equal to minus ET times t squared times x times e minus t is equal to ET to the 3 over 3 t e to the minus t. Okay, simplifies. So what do I have left? I have x dot minus t squared x is equal to e t to the 3 over 3 t. Good. What's next? Now we can identify x dot plus ATX, no parentheses here, is equal to B of T. We identify. What is A of T? Really careful here. It's minus T squared. Okay? It's not T squared, it's minus T squared. Notice difference, minus T squared. B of T is equal to this ugly thing, E T to the 3rd over 3 over T. So I hope everyone got to this step. You know, I'll let it point. You know, there was no point here. That's a typo, by the way. So once you get here, I honestly, like, it shouldn't matter. Like, I can solve it with the 2 for you guys. It doesn't matter. Just the integral is going to be uglier. Okay, so we get here. Now we compute a big A of T. What is big A of T? Integral of minus T squared dt. In your case, I think you had a 2 here. Because of the typo. So now this is equal to minus t to the 3rd over 3. Fine? Fine. Now, you have computed A. We stick to the next step, plug in the formula. I'll write the formula again. xt e minus at times a constant. I don't know why I always change these, but anyway, EAT times BT dt. Correct? Correct. Now let's see what we get. X of t is equal to E of, and we will replace slowly, minus t to the 3rd over 3 times the constant. Okay? A of t equals to this, we plug it in. Plus E minus t3 over 3 integral E minus t3 over 3 times E t to the 3rd over 3 over t dt. Everyone followed my replacement? This is B. This is just A of t. I just plugged in, nothing special at all. So now here comes a trick, because that's how I created this problem. I wanted this to simplify with this, so it simplifies. If you didn't see the typo, which is completely your fault, I don't take any responsibility for it. This would have not simplified, and the solution to this would have been very, very ugly, and I'm not interested in finding out how to solve it. So completely your fault. Hopefully, there's not gonna be typos on like this on the exam. Probably not. Hopefully not. Okay, so what do we have? We have x of t is equal to e plus t to the third over 3 constant plus e t to the third over 3 integral 1t dt. What is this integral? It's just log of t. So my general solution is e t to the third over 3 constant plus e to t to the third over 3 times ln of t. That is the general solution. General. Now, they're asking me for a particular solution such that x17 is equal to 10. What do? T equals 17 in this thing. We plug it in. x17 is equal to e 17 to the third over 3 times a constant. E 17 over 3 over 17 to the third over 3 times ln of 17. I honestly hope that on the exam the numbers are nicer than this, but you know, this is 10. So now I get the constant out. Constant is equal to 10 minus e 17 to the third over 3 ln of 17 times e minus 17 3 over 3. Anyway, some ugly number. We don't care about it. Okay, really ugly number. This is the constant. From here, I get this. And now what do I do with this constant? They're asking me for the general solution. I just write the general solution. So I'll actually explain it afterwards. And I plug in the thing. I'm not going to plug it in because it's going to look 10 times uglier than it is. So I'll actually write this. Once you have computed the constant, plug in the constant in the general solution. Good. So, you know, I'm going to write it. Plug in. Okay. And this is the solution to this problem. Now, any questions on the any questions? And no, we are not talking about that 2 in front. Any other questions on how to solve differential linear equations? Yeah, that's kind of all. Literally, I think the only tricks that they can do on you guys, literally everything that I can imagine of, is you might just have the x's on the other side or something, like, I don't know, have something like x dot is equal to t to the 4th plus 3tx, right? And you just gotta bring it on the other side. Like these are the only type of trick they can bring on you in this linear equation. It's just writing the same equation in a different way. All that you have to keep in mind is you always got to bring your equation to something that looks like this. If you try to identify a of t and b of t before you bring it to a form like this, you're probably going to end up solving the wrong integral. So I don't know, like you can imagine I can twist it and swap it however many times I want. I can move the x dot on the other side. I can have t to the 4th is equal to x dot. I don't know, like you can swap it any times. The idea is just to always bring it to something that looks like this. Once you bring it to something that looks like that, you can identify and you can just apply the thing. But that's kind of all that I had to teach for today. So yeah, if there are no questions, I'll see you guys tomorrow.